Good morning. Good morning. How are you? Hope you're well. Let us proceed with the previous discussion in measurement. And today's lesson, I want us to talk about the arc length. When you talk about the arc length, in this case, I want us to understand what an arc is. I want us to understand what an arc is and how we can obtain the length of the arc. From there, I want us to proceed to the perimeter of a sector. But in this case now, let us talk about the arc length. You're saying that that an arc here is a part or a portion of the circumference. An arc is a part or a portion of the circumference. Is a part or a portion of the circumference. An arc is a part or a portion of the circumference. Length of any arc is a fraction of the circumference. Length of any arc is a fraction of the circumference. Length of any arc is a circumference of is a fraction of the circumference. What do I mean? For example, we have a circle here. We have a circle. We have a circle. When we talk about an arc, we are saying an arc is a part or a portion of the circumference. The circumference is the distance or round. The distance round this circle. Now from there, if we talk about a distance from this point, point A, let me use a different pen. We talk about point A, here, and point B. So this one is point A, this is point B. This one, the red one here is the red sector part here is called the arc. The red part here is called an arc because you say that an arc is a part or a portion of the circumference. An arc is a part or a portion of the circumference. So it is a part. This is the whole circumference, the distance all around. But the distance AB, this part is called the arc, and this one represents the part or a portion of the circumference. Length of any arc is a fraction of the circumference of which the arc is drawn. Length of any arc. The length of any arc, we are saying, is a fraction of the circumference. Is a fraction. A fraction. This one is a whole. This one, the whole of this circle is a whole. Then this part represents a fraction. Is a fraction of the circumference of which the arc is drawn. Is a fraction, or it's a part. It's a part of the whole circumference. So in this case, when we are talking about an arc length, we are discussing about, or we are discussing the distance or the part that is A, B, or a fraction of the whole circumference. Now, the fraction of the arc, remember, a circle adds up to 360 degrees. A circle adds up to 360 degrees. So when we want to give the fraction, when we want to talk about a fraction of this arc, when we want to talk about a fraction of this arc, when we talk about a fraction of this arc, probably we have an angle. We have an angle there, and we have a radius. We have a radius. Of course, the distance from this arc, this point here, up to the half of the circle is called the radius. So we have the radius there. So when we have the radius, let me use a small r because radius is half the diameter. So when we have the radius in this case, when we want to get the fraction here, we can talk about theta, which represents the angle, all over 360 because the whole circle adds up to 360 degrees, and we are talking about theta over 360 multiplied by pi, multiplied by pi here, theta over 360 degrees multiplied by pi multiplied by the diameter, That is how we obtain the length of an arc. Or we can obtain the length of the arc by getting theta all over 360 degrees multiplied by pi multiplied by 2 multiply by 2 times r or 2r, meaning that 2r stands for the diameter. 2r stands for the diameter. So in this case now, these two methods can help you obtain the value or the length of the arc. For example, when we have an example here, we have an example. Here. Let me get you an example. Example one here, we have something like this. This is the first example. We draw it well. Then we have 60 degrees and the radius here. The radius in this case I will use 5 centimeters. I'll use 5 centimeters. Now to get the area, to get the length of the arc, this is the arc from A to B. Remember, this is a fraction. This is a part that has been extracted from a circle. This is a part that has been extracted from a circle. So to get the radius, to the length of AB, length AB can be given by pi or theta or over 360 multiplied by, let us write it here, length AB can be given by theta, which is 60 degrees. Theta represents 60 degrees. Yeah, theta is equals to 60 degrees. So theta all over 360 degrees multiplied by pi. I will use 3.14. I will use 3.14 because of the radius. I would have used 22 over 7, but it will become quite challenging. It is not direct as it would be when we use 3.14, because when we use 22 over 7, we have a denominator of 7. We multiply by the diameter. Radius is equals to 5 centimeters. Diameter is equals to 10 centimeters. So in this case, we are going to multiply by 10. We are going to multiply by 10 because it is the diameter. Let us wrap this description here. Let's wrap the description. It is the diameter. So in this case now, to get the value here, when we multiply, let me redo it here. 60 all over 360 degrees multiplied by 3.14 multiplied by 10. Now this one cancels by 6, 1 by 6, 6. Then by 2, 3 by 2, 5. When you get the answer here, will be 5.23 centimeters. 5.23 centimeters. That is the way we obtain the value. That is the way we obtain the value of the arc of the length. The length of the arc. So the arc length AB here, or the arc length AB in this example here, we can obtain it by this formula, by this expression, and we are able to get its actual value. Let me do another example. Example 2. Example 2. Let me do example 2 here, where we have a circle. I have a circle here. That way we have 120 degrees. 120 degrees. We have 120 degrees. And we have the radius as 10 centimeters. Once again, we will have to do theta all over 360 degrees multiplied by pi multiplied by d, or theta all over 360 degrees multiplied by pi multiplied by 2r. Through that, we are able to obtain the value. We are able to obtain the value of the length. So let me rub this part again so that we can calculate. Again, our theta here we know is 120 degrees, and then our radius we know is 10 centimeters. Then from there, you're going to have 120 degrees all over 360 degrees multiplied by 3.14 multiplied by, because that's a pi, then the diameter is 20. The diameter is 20 since the radius is 10 centimeters. So by 121 by 123, then when we obtain this value, we are going to have the value as 20.93. The value is going to be 20.93. The value is going to be 20.93. Value is going to stand at 20.93. Example 3. Example 3 in this question. Example 3 in this question. Example 3. Example 3 of the same. Example 3 of the same. I will have something like this. Then here I'll have 36 centimeters. Then I'll have the angle here 240 degrees. Again, it's good you observe that the radius is 36 centimeters. Then theta is 240 degrees. Theta is 240 degrees. So to obtain the value here, we are going to have our formula as theta all over 360 multiplied by the pi, then multiplied by 2r or a d. So the theta here we are going to have, we're going to use 240 degrees all over. We are going to use 240 degrees all over 360 degrees multiplied by 3.14 multiplied by 72, because that is the method, or that is the formula. So in this case, you are going to have to divide. You're going to have to divide it directly, and when we divide this one by, this one will be 1 and this one will be, we can divide by 6 first so that we can have 4 0, then we can have 60 and have divided by 20, which will be 2, and this one will be 3, 2 over 3. Then we'll have to divide this one by 1, and this one will be by 2 1 2 4. So the value in this case, is going to be, 150.72 centimeters. 150.72 centimeters. That is the way we obtain the value of the arc length. That is the way we obtain the value of the arc length. That is the way we obtain the value of arc length. Allow me to do the last example. The last example in this sector, where we have something that is quite unusual. Something quite unusual, where we'll have a semicircle. We'll have a semicircle, and we need to get the value or the length of the arc. We need to get the value of the length of the arc. So in this case, this is quite different. Because we do not have an angle. How do we maneuver, or how do we move around this? Now, in this case, first of all, you have to understand that we said that an arc is a part or a portion of the circumference. An arc is a part or a portion of the circumference. So in this case, when we talk about the arc in this case, our arc will be moving from point A here. We'll be moving from point A to point B. We have point A here and point B. Having point A and point B, that is the length of the arc. Number 2, you are supposed to understand that we said that an arc length is given by a fraction of the circumference. the fraction of the circumference. The others we have been using an angle because sometimes we might not be able to quantify with maybe a quarter, a half, and a three-quarter. But in this case, we have a half of a circle. So first of all, the most important thing is to get the circumference. Let us obtain the circumference of this semicircle. Circumference of this semicircle, the circumference of a circle is given by pi d. Circumference is always given by pi d. But now in this case, we're going to use a half because it's a semicircle. So we're going to have a half multiplied by pi 22 all over 7. Allow me use pi as 22 over 7 because in this case, 3.5 as a radius, when you multiply by 2 is going to give us 7. That's why when you use 22 over 7, it's going to be easy to deal with the diameter. So we're going to have a half multiplied by 22 over 7 multiplied by the diameter. When you multiply by the diameter, what do you have? What do you get when you multiply by the diameter? Remember, the circumference is given by pi d, but now in this case we have a half. So we are going to have something like that. 11, we are going to have 11 centimeters. We're going to have 11 centimeters, that being the circumference. But now, you need to ask yourself, have we obtained the value of the arc length? Yes, because we agreed that arc length from this point to this point is part of the circumference. And what is the circumference? Circumference is given by pi d. But again, this is a half. So we only multiply by a half here, directly gives us the arc length. So the arc length in this case is going to be 11 centimeters. The value of the arc length here is going to be 11 centimeters because it is a semicircle. Meaning when you multiply by a half, that is a semicircle is a word that represents the fraction of the circumference. So when you talk about semicircle, means it's a half of the circle. So we are talking about distance A, B. We are moving from this point here up to, so the value of the arc here is going to be 11. So that is the way we obtain the values of the arc length. Now, in the last example, this one was example 4. Example 4. Let us do example 5. Let us calculate example 5. Let us calculate example 5. Let's calculate example 5, where we still have a semicircle. This semicircle has a radius of 14 centimeters. Again, when you want to get the arc length, first of all, we know that circumference will be given by pi d. So to get the circumference in this case, we are going to have 22 all over 7 multiplied by the diameter, which is 28. But again, this one is a semicircle. The reason why we are talking about a semicircle, the arc length now, this distance from A to B, to get the distance, remember we said that an arc is a fraction of the circumference. So the fraction in this case, we are talking about half the circle. So half the circle, we multiply by a half. When we multiply by a half, what do we get? We get 44 centimeters. 44 centimeters stands as the arc length. Stay tuned as we go to the next lesson, where we'll be talking about the perimeter of a sector. We'll be talking about the perimeter of a sector. And a sector, now we will have to understand what is the meaning of a sector. Then from there, we are going to handle the other question. Otherwise, have a wonderful moment as we go to the next lesson. Thank you very much.